Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we'll continue to talk about classes and methods. We'll begin by talking about the lifetime of objects. So objects come to life, they live for a period of time, and then they die. They're removed from memory. And we'll talk about the .NET Framework runtime and its role in the creation, the maintenance, and then ultimately the removal of objects from memory. Next, we'll talk about constructors, which are simply methods that allow us to write code as developers at the moment when a new instance of a class is created. And then finally, we'll talk about static methods and properties. That static keyword's been lingering around now for some time, and we've been using static properties and static methods throughout this course, even from our very first example. So we'll finally tackle that issue in this lesson. All right, so let's begin by creating a new project. You can see I've already done that. You can pause the video and catch up to where I'm at right now. I've created a new project called Object Lifetime. Furthermore, you'll see that I copied the car definition from our previous lesson. If you like, you can type that in, help build some muscle memory, help remind you to use the prop tab shortcut, the code snippet in Visual Studio to create these shortened auto-implemented versions of properties. We'll talk about that in a little while. And then ultimately you can see in line number 13 we create a new instance of our car class. That new instance we'll call my car. And we talked about this in the previous lesson, but I felt like this deserved a little bit more explanation because there is actually a lot that's going on under the hood, and it would be helpful to understand this as we begin to work with classes and objects. So whenever we issue a command to create a new instance of a class like we have in line number 13, the .NET Framework runtime has to go out and create a spot in the computer's memory that's large enough to hold a new instance of the car class. Now that much we know. The computer's memory has addresses that are similar to street addresses, like the address you live at, the address that I live at. Now admittedly, a computer's memory addresses look dramatically different than our addresses, like 123 East Main Street, because the computer's addresses are typically represented in hexadecimal values, but they're known addresses nonetheless, and it's easy then for the computer to find something in its memory by using its address. So the .NET Framework's first job is to find an empty available address where nothing is currently living, where there's no data that's currently being stored, and that address has to be large enough to store an instance of our class. So the .NET Framework runtime will then create the object instance, and it will copy any of its values that are currently stored in that object instance up into that memory address. Then it takes note of where it put that object. It notes the address of the memory where it put that instance of our object, and then it serves that address back to us, and we store that address in the actual name of, or the instance name of our class, in this case my car. That variable is actually holding on to a reference, or in other words an address in the computer's memory where we can access that object once again. Now whenever we need to access the new instance of the car class, we merely can use its reference name. It's in this case my car. So my car is simply holding an address. It's simply a reference to an instance of, in this case, a car class in the computer's memory. Whenever you need to work with that instance of the car class, you just use the myCar identifier, and the .NET Framework class library, the .NET Framework runtime takes care of everything else for you. It gives you the illusion that you're actually working with the object itself, but in reality, you're just holding on to a reference to an address in the computer's memory. Now there's an analogy that helps me to sort all this out in my mind, and we're going to continue to extend that bucket analogy. If that object is stored in the computer's memory, and if it's what we have equated to a bucket, an address, an area that holds on to our values, then what's returned back to us as programmers is a handle. That's what my car is. It's our handle to the bucket. And we've used that bucket analogy a number of different times, and it's served us well. But we essentially are storing values in that bucket, just like we were before, and we're holding on to that bucket using our reference to that memory area in our computer's memory. So what happens if we were to let go of the handle? Well, at that point, we'll no longer be able to get back to the bucket. We've lost the bucket somewhere in the computer's memory. The bucket will no longer be accessible to us. Now, can we ever get back to that bucket? Well, no. What happens is that the .NET Framework runtime will be constantly monitoring the memory that it manages, and it's looking for objects that no longer have any handles associated with them. So once we let go of a handle, the reference count, the handle count, I guess you could call it, will go to 0, and at that point, the .NET Framework runtime will say, I see that nobody's interested in you anymore. They've let all of their handles to you expire or to go out of scope. So that must mean that you're no longer needed, and it removes it and throws it in the garbage. And so that process of monitoring memory, looking for objects that no longer have any references to them, is called garbage collection. It's one of the core features of the .NET Framework runtime. And it's one of the reasons why it's easier to work with C# at first as a developer than maybe going directly to C++. In an unmanaged language like C++, you, the developer, may have to manage memory on your own, and sometimes you might forget that you actually are leaving things in memory and you're not cleaning them up, you're not removing them yourself, so your application might have a memory leak. Or you might have a corrupted memory region where you're using an area of memory and you forget that you're using it, so you copy something else to that area of memory. Now you go back to retrieve the value that you originally put in there, and it's corrupted. So that leads to corrupted memory in applications. You don't really get that issue so much in C# because, again, the .NET Framework runtime takes care of all the memory management for you. All right, so let's do a little experiment here. If we said that we can have one handle to a bucket, what happens if we attempt to create a second handle to the same bucket? So let me do this real quick. Let me go to my car and start setting some of the properties, like the make equals Oldsmobile. Then we'll set the model equal to the Cutlass Supreme. And then we'll set the year equal to 1986. And then finally, we'll set the color to silver. All right, now keep that in mind. We've created a new object called that we're referencing using the myCar identifier. This car class instance of the car class lives in memory, and we're holding on to it with a handle called myCar. But what if we were to create another car like this? So my other car. What have we really done right now? We simply have created a handle, but we've not attached it to any buckets of cars in our computer's memory. So at this point, what I could do is go my other car equals my car. Now, what have we really done there? Well, we've merely taken one handle to a bucket in memory, and we've created a second handle and said, hey, let me copy your address, so that we're both referencing the same bucket in the computer's memory. Now, to prove that, what I'll do is do a console.writeLine, and we will do what we did before. Whoops. All right, and just give me a second here. And we'll reference my other car's make, my other car's model, my other car's year, and then my other car's color. Let me separate these to different lines for readability's sake, like so. Whoops. All right, and then a console.readLine for good measure. Now let's run the application. All right, and you can see that even though we created or set the properties of my car, since we copied the reference to the car object in the computer's memory into a new variable called my other car, I can still get to the values that are in memory because they're both pointed to the same object, right? And now I can even do something like this, where I actually change something. My other car dot, let's set the model equal to the 98. That was the large style model for that car. And let's then go back to and do something similar to this, just to prove that they're one and the same here. And I'll say, hey, let's do that, okay? So we're going to use our reference called my other car and set the model, change the model from the value Cutlass Supreme to the 98, and then we're going to say, hey, show me what's in the my car object, all right? So now we're going to run the application, and you can see now we're printing out what's currently in my car. It's the same thing that we changed in my other car because they're both pointed to the same place. I just want to emphatically make that point here. All right? Okay, so as you can see, we have now two references to the same object in memory. We essentially attached a second handle to the same bucket so that we can use either one to retrieve the data in the bucket, so to speak. All right? If you don't like that analogy, maybe it helps to think of this in terms of balloons. So I have a balloon and I have two strings tied to the balloon. What happens when I cut the first string? I'm still holding on to the balloon, but what happens when I cut the second string? The balloon now will fly away and we'll never see it ever again, okay? So as references go out of scope, in other words, whenever the current thread of execution leaves the current code block that we're currently in, or those object references are set to null intentionally by the software developer, then the number of references to the object, the number of handles to the bucket, the number of strings attached to the balloon, they go to 0. And so here again, when the .NET Framework runtime looks through memory and finds objects that have a reference count of 0, it will remove those objects from memory. So we talked about the two instances in which the connections to the object get removed. One is that the reference goes out of scope. So whenever we create a new variable called my car, it will continue to be in scope as long as we're inside of this main method. But once we exit out of the main method, that variable goes out of scope. It's no longer available for us to access any longer. The same would be true if we created a method, a different method, and defined a variable. And as soon as we go out of scope of that method and we have finished executing all the lines of code in that method, then any of the variables that were declared inside of that method go out of scope. And in this case, we would lose then any references to the objects that we created in the context of that method. All right? So that's one instance in which we'll lose references to objects that we've created. But the second is if we, as the developers, actively take a role in cutting the strings or removing the handles from the buckets in memory. And the way that we do that is by setting our objects equal to null. The value null is not 0 and it's not an empty string. It just means indeterminate. In this case, what we'll do is go here and we'll set my other car equal to null, like so. And when we do this, now we'll remove one of the handles to the bucket, so we're back to just one handle in the bucket. To prove this, let me go ahead and copy this little section of code and go here and put it below this. And when I do that, notice what happens. We'll get an exception. The exception is that there's a null reference exception that was unhandled. And the reason why it was a null reference exception is because we have now removed the handle. The handle does not point to any objects in memory, and yet we're still attempting to access values from the object in memory, so we get an exception in our application. All right. Now, what were to happen if we were to remove the second reference, like so, my car equals null? All right. Well, at that point now, we have removed all the references to the bucket. Even if we were to attempt to get to it with either my other car or my car, either way, the references are gone completely, and so now the object will be removed at some indeterminate time in the future by the .NET Framework runtime. And so in some situations, this indeterminate period of time can cause a problem, especially when the object in memory is holding on to some special resource, maybe something like a reference to a network connection or a file on the file system, or holding on to a handle to access a given database. So again, we don't know exactly when the .NET Framework runtime will actually execute the garbage collection step, and that might pose a problem in certain situations. In these cases, you would want to use a more deterministic approach to requesting that .NET removes the object from memory, and if necessary, will finalize and clean up anything that needs to happen inside of that object to completely get rid of it in the computer's memory. So in these cases, you want to learn about deterministic finalization. That's a little bit of an advanced topic, so we're not going to talk about it in this series of lessons. Just keep in mind that whenever we set reference to null, or whenever we go out of scope, we will be removing all the references to our objects, but the .NET Framework runtime itself figures out when it's ready and willing to remove those objects from memory completely. In most cases, that's not a problem. Occasionally, you're going to run into a situation where it is a problem. Know that there is a remedy for it called deterministic finalization. Okay, so that should suffice our explanation of really what's going on whenever we create new instances of objects, how objects are maintained in memory, and then at what point they're removed from memory. So let's move on and talk about constructors. And I said at the very outset that a constructor is merely a method that allows us as developers to execute code at the moment that a new instance of a class is created. So there's something really subtle about what's going on here in this line of code, line number 13. Did you notice that whenever we use the new keyword and we give it the name of the class that we want to create a new instance of, that we're also calling it using the method invocation operator? Why do you suppose that is? Whether you realize it or not, you're calling a method whenever you create a new instance of a class, and that method is referred to as a constructor, and it allows you, the developer, the option. You don't have to do this, so it's an option to write some code at that very moment whenever a new instance of a class is created. So constructors can be used really for any purpose, but typically they're used in order to put that new object into a valid state, meaning that you can use it to initialize the values of the properties of that given object, and so it's immediately usable. Now, let me give you a really quick example here. Let's say that you want to create a constructor that would allow you to set a property of the car at the point whenever you create a new car class. So that property is available immediately in the very next line of code whenever we begin to work with it here in line number 15. So whenever you actually want to create a constructor, you would go and create something like this. Public car. And in this case, what I'm going to do is simply set the make property to Nissan. So by default, whenever we create a new car class, we're going to set one of its properties, the make property, to Nissan. All right. Now let me say this as well. You might see the keyword this used. The this keyword is optional. It refers to this instance of this object, and it's just to help clarify where this variable name or this name is coming from. When I see this keyword, I automatically think, oh, that's part of the declaration of the class itself. It's saying that you want to access a member of this class that's been created, okay? But as you can see, it's kind of faded out in my text editor. It might not be in yours, which lets me know that I could actually remove this. It's not necessary, all right? So you might see that though in other people's code. Just understand what that is. All right, so now if we were to go ahead and create a new instance of the car class, here's what I'll do. I'll actually comment out all of this code like so, and then I'll comment out the code that we know will break the application. Well, we can leave the rest of it, I suppose. Now whenever we run the application, notice that the very first item that is displayed is the make of the car, and it's set to Nissan. So I didn't set any other properties. That's why we didn't get any other values there in the printout, but hopefully you can at least see how we go about creating constructors. Now admittedly, it may not make a lot of sense right now why you'd want to do this, but I'm showing you the technique you'd use, not the rationale necessarily. But the rationale is simple. What we would typically do here is to put any new instance of an object into a valid state. So you could load values into the various properties of your class from a configuration file or from a database or some other place in order, again, to get that object into a valid state so that it's immediately usable at the point of whenever it's instantiated. All right. So let's go ahead and talk about overloaded constructors. You'll see this frequently whenever working with objects in the .NET Framework class library. So just like you can create an overloaded method in your classes by changing the method's signature, in other words, the number and the data type of the input parameters for the method, you can do the same thing with a constructor. You can create an overloaded constructor. So what I'm going to do is create an overloaded constructor here, like so. Now, at this point, the method signatures are the same, so I'm going to get a little error here. But to modify that, I will merely add at least one input parameter of type string. But I'll go ahead and do them all as well. So, and then here in the body of the constructor, I would just do make equals make. So this capital M make is in reference to the property itself. This lowercase m in make is the name of the input parameter. It's a good convention to use the same name for readability's sake and for your own sanity. You don't have to do it this way, but just keep in mind that uppercase M and lowercase m are create two different items in as far as C# is concerned. Okay, so it's not confused. You might be confused, but we'll be able to handle this just fine. Okay. Now you might ask, well, what's the point of that? Well, in many cases, whenever you create a new instance of a class, typically you don't want to take 5 steps to do this. You would want to immediately, whenever you create a new instance of a class, so car, my third car equals new car, at this point you can do one of two things. Notice here that underneath car, underneath the open parenthesis, I have one of two ways that I can call the constructor. I can either give it no input parameters, or I can give it 4 strings as input parameters to initialize that new instance of car and put it into a valid state immediately. So here I might go forward, escape, 2005, white, like so. And now I have not only created a new instance of the car class, but I've immediately initialized its values by calling its overloaded constructor to populate all of its values at the moment of instantiation. All right. So what were to happen if we were to actually remove these two completely? What if we were to comment these out? What happens? So you can see that we're still using the method invocation operator for our new instance of car. That would suggest that we're calling a constructor, but we don't have a constructor defined. So why is this working? Why isn't it giving us an error? Well, the reason is because a default constructor is automatically created for you whenever you compile your classes. It will be a constructor without any input parameters, and it will have no body. But it's essentially the equivalent of doing this right here, except with nothing inside of it. All right, so that's created automatically for you. So no matter what, you're going to have a constructor. It just won't do anything for you. The implicit default constructor has no input parameters, no method body, but it allows you to make calls and create new instances of classes in a consistent way. So it's actually just generated for you, again, at compile time. Of course, by defining it yourself, you're taking control of the process of instantiation. All right, so let's talk about the static keyword now. You've seen static around since the very beginning. I said let's ignore that for now. We created our own methods, and I said we have to use the keyword static. I'll explain later. Well, now is the time. So I want to ask a question. Did you ever notice that whenever we were working with the console window, we never had to create an instance of console, the console class, in order to call its methods, right? And that it combined with the fact that whenever we wanted to work with date time, we could get to this moment in time by using the datetime.now property, but we never had to create an instance of datetime. Furthermore, whenever we were actually working with arrays and we wanted to call the reverse method, do you remember we did array.reverse and then we passed in the array itself? How is it that we were able to use the reverse method without creating an instance of the array class? Well, in each of these cases, the creators of those classes, or specifically those methods, adorned their methods with the keyword static, which means that you do not have to create an instance of a class in order to utilize that method. In some cases, they may have defined an entire class as static, meaning that all of its properties and methods were static. So you can create your own static methods and classes as well. Again, the objective here at the very outset is to just help you utilize the .NET Framework class library. So just know that some of the classes and methods in the .NET Framework class library are static, and some are instance, or require you to create an instance of the class before you call its methods and properties. All right. So the static methods will be available to you without first requiring you to create an instance of a class. So just so you can see how this works, we can create a static method on our car class, like so. In this case, we'll go public static void my method. And here we'll do console.write line called static my method. All right. And now we can go here near the very top and just say car.myMethod. And notice I didn't have to create an instance of car. I'm using the actual car class definition itself when we run the application. All right, and before we go too far here, let's comment out pretty much everything. Let's remove that, and we'll go down here. All right, just make this so that we don't run into any potential issues here. So let's run the application, and you can see that we were able to successfully call the static my method. Now, what would happen if we attempted to reference one of the properties in our class? So let's just print out the make property. Notice that I immediately get a red squiggly line beneath the word make. It says that an object reference is required for the non-static field method or property called car.make. So it's important to keep in mind that there's a fundamental difference between working with classes that have static members versus instance members. Instance members are the things like we've been working up to this point, where we have a series of properties that describe a single instance of a given entity, like a car. There might be methods that operate on a single instance of a car, like the constructors that we saw. Whereas a static member, like a static method in this case, they don't really operate on any single instance. They're more like utilities. You can call them at any time. They don't depend on the state of a given instance of the class or even the application itself. They can be used at any time because they're not really tied to one specific car. They're true of all cars and can be used at any time. All right, so static members versus instance members. Just keep those two clean in your mind. Now, you might want to ask the question, why would you ever create a static member like a static method? Well, that's a bit more complicated. That might require a longer discussion of things like design patterns, which are common solutions to common problems for software developers, or coding heuristics, which are more the best ways to go about solving problems. I just want you to know that there's a fundamental difference between static members in a class and instance members of a class, and it's easy to recognize them. If it's a static member, it'll have the static keyword, okay? And in which case, you cannot reference any instance members, like instance properties or even other instance methods that act on instance properties, all right? They require an instance of the class to operate. So just know that there are these two types of members in a given class, and that you're going to encounter both whenever you're working with the .NET Framework-based the class library. And why you would use one or the other, well, that's really, again, another story. I would say this, that typically I would recommend that you don't mix and match them in the same class. Clearly not everybody agrees with me, because you'll find that many times. But it's not really important at this point to understand why you would use one over the other. Just know that that possibility exists. That's why you don't always have to create an instance of a class before you use the members of its class. In this case, a given method. All right, so let's recap what we talked about in this lesson. We began talking about the lifetime of an object, how we create a new instance of an object, what that's doing in terms of creating an area in the computer's memory, returning back to us an address, a reference to that object in memory, what happens during the lifetime of that object, and ultimately what happens whenever we remove all of the references to that object. We talked about the role of the .NET Framework runtime and how it's keeping track of the number of references to objects so that it can perform garbage collection on objects that have no more references to them in memory, as a means of keeping things clean and making the memory available to other applications, or even our application again. We talked about constructors and how developers can use them to put a new instance of an object into a valid state at the point when that object is created. Then we talked about the static keyword. We looked at some usages of static members inside of the .NET Framework class library. We looked at creating our own static member, this main or this my method. We talked about the difference between static members and instance members and how it's really oil and water. You can't mix the two, and why that is. We didn't really talk about why you would choose to use one over the other. However, that's, again, a topic for another day. So hopefully all of these concepts make sense. If not, don't continue on and hoping that you'll just catch up to them at some point in the future. Make sure you thoroughly understand this before you continue on. Okay? If you are continuing, great. We'll see you in the next lesson. We'll see you there. Thanks.